Leetcode 698. Partition the array into k non-empty subsets, all with equal sum. First check divisibility, total sum must divide by k. For the classic example, total is 20 and k is 4, so each subset must sum to 5. A valid split exists, 5, 4 plus 1, 3 plus 2, and 3 plus 2. Second example, 1 2 3 4 with k 3, total is 10, not divisible by 3, so the answer is false immediately. You must split nums into k non-empty groups, each with the same sum. That common sum is total divided by k, so the total must be divisible by k before any search makes sense. First, the idea in one line, we encode which numbers are already placed using a bit mask, 1 bit per index. Index I lines up with bit I in the mask. A 1 means that number is already placed in some bucket, zeros are still free to pick. For 2 indices there are 4 masks, from nothing used to both used. The search walks through these by setting 1 bit at a time when you place a value. Fix nums as a small example. Each mask is a binary string, a 1 in position I means index I is included in that subset. Read off the chosen indices, plug in nums at those positions, and add, that is the subset sum for that mask. The forward algorithm walks masks in order, how we store progress in a table is in solution, not here. For this demo the sum is 4 and k is 2, so each bucket must sum to 2. If remainder k were non-zero we would return false before building the DP table. On the left, target is the required sum per bucket, with k and nums for this demo. The table has 8 rows, 1 per mask from 0 to 7, 3 bits for 3 indices. Initialize DP at 0 to 0 and every other row to -1 until a forward transition lands there. That was 3 branches out of empty mask. Each box showed new sum and new mask, then we filled rows 1, 2, and 4. Same pattern for mask 1, 2 more first writes landed in rows 3 and 5. This branch fails. From mask 2, index 0 makes the sum exceed target, so we skip, the table does not get a new row. The red box marks a dead try. After that, mask 6 and then mask 7 get their first writes, finishing the forward pass. The table is already filled, but the outer loop still walks masks 4 through 7, same relax rule, sometimes overwriting a cell. At full mask, no free index. We return DP at 7. Row 7 is 0, so the partition exists. The 2 lines under the table are the relax step, pseudocode has the full nested loops. N is the length of nums, k is how many equal sum subsets we need, and target is sum divided by k after the divisibility check passes. Time is order n times 2 to the n, for each mask you scan up to n indices, and unreachable mask skip in constant time. Space is order 2 to the n for the one-dimensional DP array. The iterative forward DP needs no recursion stack. Pseudocode for 698, check divisibility and target, allocate a DP array of length 2 to the n, then double-nested loops over mask and index, relaxing new sum mod target into each new mask. Outer function takes nums and k. Total sum S is sum of nums. If S remainder k is not 0, return false. Target is S divided by k, the required sum per subset. Let n be the length of nums. Let m be 1 left shift n, the number of bitmask states. Allocate dp of length m, filled with -1. Set dp at 0 to 0, nothing used yet. Outer loop, mask runs from 0 to m-1. If dp at mask is negative, skip, unreachable state. Inner loop, I runs from 0 to n-1. If bit I is already set in mask, skip. Newsum is dp at mask plus nums at I. If newsum exceeds target, skip. New mask is mask or 1 bit shifted left by I. Relax, dp at new mask equals newsum remainder target. Return whether dp at full mask m-1 equals 0.